This video is a continuation of the first practical timing technique video. Quick recap. On the first video, the video demonstrates on how different diameters and motion travel in different inches per minute. The chuck having a larger diameter covers more space and less amount of time, in comparison with the smaller pipe's diameter, which covers less space and the same amount of time relative to the chuck size, and both rotated by the positioner's rotational force, which results in a time dilation effect that allows for two different results under the same rotational force. So in this video, I will demonstrate how to approach and achieve weld size symmetry between a longitudinal seam and a circumferential seam with the use of a soft tape and a stopwatch. So in this segment, I'm starting off with the longitudinal seam. This demonstration of the long seam will be clocked to 60 seconds. So both the arrow and the subarc stem are the reference points for marking time. Being displayed on the top right-hand corner from a different camera angle is the subarc carriage in motion marking time. In this demonstration, the use of a soft tape along the length of the seam makes it a far better approach in this situation than marking 1-inch increments with soapstone throughout the long seam. So as the stopwatch gets close to the 1-minute mark, the word "N" appears, time stamping the inches per minute in real time, which the travel speed was clocked at 25 inches per minute for the long seam. In this segment of demonstration, I'm clocking the long seam in 30 seconds instead of 60 seconds. It's a shortcut for the 60-second or 1-minute method. I call this half timing. You can also time at 1/4 inch timing, but it's always better to run full timing 60 seconds if you're not too familiar with the equipment, especially older equipment, which might have nose and electrical components and wear and tear and mechanical components. It would be a better approach to run the whole 60 seconds to get a more accurate inches per minute. On this segment, I will be applying the same method with the circumferential seam. The demonstration will be in half time, which I will clock to 30 seconds. In the top right corner and display, you can see the tank being rotated by the turning rollers. So instead of the subarc carriage being in motion with the stem marking the inches per minute, the carriage is stationary and the tank is being rotated. So as demonstrated in prior segments on how to achieve symmetrical weld size on both the long seam and girth seam by timing the carriage and rollers to travel at the same inches per minute, and the carriage having a digital control and the rollers having an analog control, and having the ability to match travel speeds gives you the ability to also troubleshoot equipment for any mechanical or electrical inconsistencies in real time. The use of this timing technique across different welding applications gives you the ability to use weld parameters on multiple positioners, rollers, and carriages to achieve consistency and reliable visual results, regardless of the diameter size for rotational motion or length size for linear mode of travel, or the practicality to still acquire travel speed on faulty or damaged digital or analog controllers. In the next video, I will demonstrate on how to acquire time and inches per minute with the same technique with handheld manual processes like stick, TIG, MIG, and flux core. Stay tuned.